Your Bibles to Job chapter 6 and verses 15 and 16. And what we're doing is we're looking up the word ice. Ice, I-C-E. And the word ice is used 3 times in the Bible, and we're going to go to those verses. But we're going to read just a couple verses with some of those verses. In Job chapter 6, and I'm going to read verse 15 and 16. And this is Job speaking here. And he says, "My brethren have dealt deceitfully as a brook, and as the stream of brooks they pass away, which are blackish by reason of the ice, and wherein the snow is hid." Some translations speak about this brook or this stream as being a turbulent kind of water. In Job chapter 38, now we have God speaking here in this particular chapter. And God, of course, giving his challenge to Job and the others, partially here in Job chapter 38. And I'm going to read verses 25 through 30. 25 through 30. He says, "Who hath divided a watercourse for the overflowing of waters, or a way for the lightning of thunder, to cause it to rain on the earth where no man is, on the wilderness wherein there is no man?" Verse 27, "To satisfy the desolate and waste ground, to cause the bud of the tender herb to spring forth." Verse 28, "Hath the rain a father? Or who hath begotten the drops of dew?" He's challenging these men. He says, where did all this come from? You didn't make all this, did you? No, of course not. Now let's continue. Verse 29, "Out of whose womb came the ice, and the hoarfrost of heaven? Who hath gendered it? The waters are hid as with a stone, and the face of the deep is frozen." Now, it doesn't say the deep is frozen. Notice that. It says the face of the deep is frozen. That's important. We'll come back to that in a minute. Now let's go to Psalms 147. Psalms 147. And we're going to start in verse 12. Now, the verse we're looking at specifically is 17, but we're going to go 12 through 18 because we want some context and larger understanding of this. He says, "Praise the Lord, O Jerusalem. Praise thy God, O Zion. For he hath strengthened the bars of thy gates. He hath blessed thy children within thee." Verse 14, "He maketh peace in thy borders, and filleth thee with the finest of the wheat." Verse 15, "He sendeth forth his commandment upon the earth. His words runneth very swiftly. He giveth snow like wool. He scattereth the hoarfrost like ashes. He casteth forth his ice like morsels. Who can stand before his cold? He sendeth out his word, and melteth them. He causeth his wind to blow, and the waters to flow." Who made all these things? He says God made them all. God made them all. Now, we're going to move our camera over this way just a little bit, just so you have some warning there, Mike, and you might have to widen it out just a little bit here. But we have a little table here with some things on it, and we're going to be doing a little experiment here this morning and talking a little bit about water and ice, because the ice is made from water. Not too hard, right? Frozen water. Now, water is very unique. Water is a composition of 2 parts hydrogen, 1 part oxygen per molecule. And these molecules use something very unique in chemistry called, not necessarily totally unique, but not widely spread either, called hydrogen bonds. It's a special type of bonding, and this is very important. It's very important. And if you think about hydrogen, hydrogen is a very combustible gas, isn't it? I mean, do you remember the story of the Hindenburg, right? Okay. And oxygen, Alan, when you're welding or cutting with a gas torch, you use acetylene and oxygen. And the acetylene burns and the oxygen is the activator that makes it really go, right? And so you've got these 2 things that really are used for combustion in such a great way. But you put them together, you get water, and we use it to put fires out. Isn't that interesting? But now in Job, we read about how he covers the face of the deep with his ice, right? Have you ever thought about ice? Now, I've got some water here, by the way, and This water right now, it says it's setting at about 75 degrees with this chemical thermometer I have, and I have a thermal thermometer here, infrared thermometer, and it's saying 75 too, so they're sort of in agreement right now. That's good. But when I take the ice, and I'm going to put it in the jar, and you can zoom in on that if you wish, Mike. But what happens to the ice? Notice when I drop it in, it goes, because of the weight, it goes to the bottom and then it pops up. Why does it do that? It's lighter than the water. Well, it's the same weight in a sense of the water, but its density now is different. It's made of water, but the density of the water that is frozen has changed. The density is less because it is expanded. It has the same weight or mass in the sense, they're not technically the same, but anyhow, because it is less dense, it floats. And that's important. Because if it didn't float, if it froze and sunk, the next layer would freeze and sink, and freeze and sink, and all of your lakes and rivers and streams and even oceans would eventually just become solid ice because they would never have enough heat to thaw out, you see. And so this keeps, but when it freezes and stays on the top, then it forms an insulating layer so that the bottom below it doesn't freeze. Isn't that good? Now, you know something? You can take water, this is interesting, and you can add some salt to it. Now, we use what we call table salt, which is sodium chloride, but there's all kinds, excuse me, there are all kinds of salts. The salt that we usually use when we're melting the ice on roads is called calcium chloride. And I won't go into a big thing about the salt today, but I'm going to put some salt in here. Not a little. So I want to make sure it gets some in there. And I'm going to stir it up. And actually, I should have taken the ice out sooner. Sorry I didn't do that. It's already almost melted. Because I should have reversed this process, but I didn't. But you know, if I take this now, and of course it's had ice in it, and so it's going to be colder, we know that. But actually, if you were to take this, says it's about 60 degrees now. If you were to take this when it was 75 degrees, and you were to put salt in it and stir it up, it would probably measure about 73 degrees. It would lower the temperature of the water. And in fact, we're going to take some ice and put it here in our bowl. Now, how cold should the ice itself be? How cold should the ice itself be? It's frozen. About 32 degrees. That's right. We'll add a little water in here just to help it a little bit. But now, I'm going to pour some salt in here. Make sure there's plenty of salt in there for it. And I'm going to stir it up a little bit now. Anybody ever make homemade ice cream? You can this way, don't you? In fact, this is what you do. Now, this is interesting. This is interesting. Usually, if I wanted to melt this piece of ice, just holding it in my hand will melt it. Why? My hand is warm enough. If my hand is over 32 degrees, it's going to melt it, right? So if I put salt in the ice and it melts it, it should be getting warmer, right? You'd think it'd get warmer. But no, it's getting colder. It's getting colder. It's not 32 degrees in there. It's like 3 degrees. 3 degrees. It's gotten really cold. Wonder why? What's happening in there? What has the salt done? You see, when you heat something up, you generally are adding energy. But if you cool something down, you're subtracting energy. So you have these water molecules, and they're always moving. Molecules are always moving some. In anything, steel, wood, molecules move. But when they get colder, what happens? They slow down. And when they slow down, they don't produce as much energy, and that means they don't have as much heat. That's right. So now what we're going to do, we're going to do something that we have to let cure for a few minutes. And so while it's curing, we'll have our song service. But I'm going to get a couple little baggies here. Have them right here. And I'm going to open this baggie up. I have just a little bit of orange juice left in this jug here. Not too much, but probably enough for what we want to do. I'm going to pour it in the baggie. Okay, hopefully I get it right. Just perfect. Just the right amount. Thank you. Thank you. I'm going to seal this up now. Try to get most of the air out of it just to make it work better. Okay, there we go. That's part one. Part two, the bigger bag. The bigger. What do you think is going to go in the bigger bag? Ice. Ice. I should have got a scooper from the church, and I didn't. I'll just use my hands. You'll excuse my hands, right? It's okay. And we'll pour just a little of that in there. Pour it all in there. We're going to add some more ice in here. Make sure we have plenty. And we're going to add some more salt in it because we like salt. Good for the soul. Don't want it to lose its saltiness, right? Okay. So now, get most of the air out of that. Now comes the important thing to do now. I hope that works. Now we have our piece of insulation. I'm going to roll that up. I'm going to let it cure for a little bit, see what happens. How do you think? And we'll come back right after the song service later. But remember we had some water that was sort of at the room temperature, and do you remember how much it was before we put salt? It was 75, and it's stabilized now, and it's down to about 72 degrees, which is about what we predicted it would be with some salt added into it. But we took some orange juice, put it in a plastic bag, and then we wrapped that with a bag that had ice that had been salted in it, remember? And then we insulated it, and so now we're going to find out what we got left. We're going to find out what actually happened here now. So we're going to unwrap it. Oh, that's cold. That's cold. And you know what we have now? Oh, listen. It's not ice cream, I guess, because ice cream is made from cream. This might be more like a little slushy or a sorbet, yeah. And so we take this, and I'm going to put it in the little bowl here, and you can zoom in on that part if you can, Mike. I don't know if you can get down in there or not, but we're going to put that there. And then you see I had another little bowl. Did you see what was in the bowl yet? Blueberries, yeah, why not? Put some little blueberries in there. And then you have just a little refreshing treat for those days that are just a little bit on the warm side. You know, and it's all natural and nice. And anybody want to be the tester? Oh, no one said it quick enough, so I'm going to have to try it.
If it had been milk, it would have been orange ice.
It's pretty good. Pretty good. So now you know how you can make a little treat, but you know why it works because of the salt and the ice. Thank you so much. And I hope it has been a blessing to you. But remember, it's God who made the ice, God who made the water in such a special way that when the ice forms, it doesn't sink, it floats. And God is so masterful. I was thinking this morning, when God was creating everything, He probably said within His heart, I'm going to do this in an artistic way. Now, it might not seem like art to you, but within the field of science and physics, this is artistry. This is beauty. And God is so good. Thank you so much.